Here's a look at how to do number 6. It has its little challenges in just finding an inflection point. Sounds simple enough. Get the first and second derivative, set the second derivative equal to 0. It also wants the coordinate point of the maximum, so you have to take the x that you solve for, that you get when you set the second derivative equal to 0, and you have to put it back in the original function f, so that you can get the coordinate point of where that maximum or minimum, or I'm sorry, where the inflection point is located. So what I'm going to do is just kind of show you pieces of this at a time. Here's an example. Here's the problem. It's a product rule. X times 4 minus x quantity squared. You can FOIL that all out, multiply it all out, and do a derivative that way. But I wanted to show you a product rule because I don't want you to shy away from product rule. They never go away, so keep those in mind. So the product rule in this one, it's an x times 4 minus x quantity squared. So I'm going to treat those as two multiplied functions. And the second function requires a chain rule, which we always can use an extra chain rule review. So here it is, the derivative of the first function, 1, second unchanged, plus the derivative of the second, that 4 minus x quantity squared. You have the derivative of the outside, so you see the 2 come out front. Inside untouched, 4 minus x. Now it's to the first, I didn't write that. And then times the derivative of the inside. Remember, chain rule is times the derivative of the inside, which would be -1. And then the last part is the first function unchanged. So there's the derivative, and then I'll simplify it here. So, you have to FOIL out the 4 minus x squared, distribute what's now a -2x. When you put some of this stuff together, like the 2x and the -1 all together make -2x, and then I distribute it into 4 minus x. So some good algebra there. FOILed out the 4 minus x squared. You can see that in the red bracket there, the contents of that. So I tried to show you where the work happened. Combine those, so I simplified f prime of x down to this lovely function here, 3x squared minus 16x plus 16. The second derivative would be to take the derivative again, so 6x minus 16. You set that equal to 0 and solve for x. That's the x coordinate of the inflection point. But you have to go further than that. You have to put that x value into f of x to get the y coordinate, which I'll do next. So I'll set that first derivative equal to 0. Solve for x, 8/3, gotta like the fractions. Now I gotta put it back into the function because that's the x coordinate. I need the y coordinate. So it's the original function. Derivatives speak to the original function, so don't forget to put it back in the original. So here it is going into the original function, and then there's some work to be done there. So there's me making 4 into 12/3, so I can combine those fractions, and then squaring the fraction, and then multiplying it out, 128/7. So the coordinate point 8/3 x, coordinate of the IP, and 128/27 is your y coordinate. Hope that helps.